channel. I will demonstrate Per Vlan Spanning Tree configuration and verification in this video. Let's look at the Per Vlan Spanning Tree scenario. In this network, we have two VLANs created, VLAN 10 on ALS1, VLAN 20 on ALS2. By default, the Per Vlan Spanning Tree is running on all switches. So as we can see right now, Spanning Tree is blocking the right side port on the access layer switches for both VLANs, and the Per Vlan Spanning Tree has already created two Spanning Tree topologies. One for VLAN 10 blocking right side port, and the second for VLAN 20 again blocking the right side port. So basically right now, the default behavior, if we drag the two VLANs to the similar shape, you can see the two Spanning Tree topologies are the same. All the traffic going towards DLS1, and DLS2 is not in use because the right side links are Spanning Tree blocked, no traffic. The purpose of running Per Vlan Spanning Tree is try to accomplish load balancing, that both distribution layer switches are used, and the traffic from both VLANs are distributed between two distribution layer switches. So that is the load balancing we want to accomplish. So let's see how do we configure. So basically, we just configure DLS1 as a root bridge for VLAN 10, DLS2 as a root bridge for VLAN 20. Then the VLAN 20 will use the right uplink. Now we are configuring DLS1 as a root bridge for VLAN 10. In the meantime, it is the secondary root bridge for VLAN 20 as backup. Spanning Tree VLAN 10 root primary. As soon as we configured Spanning Tree VLAN 10 root primary, the DLS switch will lower the bridge priority on DLS1 to ensure DLS1 is having the lowest bridge priority on this network. So it will become the root bridge for VLAN 10. Now we're going to configure it as secondary for VLAN 20. Spanning Tree VLAN 20 root secondary. As soon as we configure this DLS1, we'll choose the second lowest bridge priority for VLAN 20. If we check the running config, we can see it automatically set the priority for VLAN 20 as the second lowest, 28,672. The VLAN 10 priority is the lowest, 24,576. Let's go to DLS2. Configure DLS2 as root bridge for VLAN 20. Spanning Tree VLAN 20 root primary. In the meantime, configure DLS2 as root secondary for VLAN 10. Go to ALS2, check one port will be blocking, and ALS2 show Spanning Tree. Looking for VLAN 20 specifically, we can see VLAN 20. And port 2 is blocked. Port 2 is the one connected to DLS1. And currently root port is F01. That is the primary link going up to DLS2. The root bridge, we can see 000D root bridge is the DLS2. Let's check it out. Show spanning tree, VLAN20 specific. This bridge is the root. DLS2 is the root bridge. Now, mission accomplished. VLAN20 traffic is using this uplink, and port 2 is blocked. This is the Per Vlan Spanning Tree configuration. Once we configured, we can verify it. Simply just show spanning tree. We can see the spanning tree topology is created for every VLAN on the network. VLAN1 has a spanning tree topology, which the root bridge is 001. That is different from VLAN20. Going down, VLAN20, the root bridge is 000D. And right now on this switch, I have only 2 VLANs created. If I create one more VLAN, VLAN 10, you will immediately see the third spanning tree topology, VLAN 10. So now there are 3 spanning tree topology. VLAN 1, VLAN 10, and the third one, VLAN 20. This is Per Vlan spanning tree. The switches create and maintain the spanning tree topology for every VLAN you created. As the number of VLAN increases, for example, we increase the VLAN to 20 VLANs, then the switch will maintain 20 separate spanning tree instances, one for each VLAN. Then that will consume a lot of switch resource. And this is not efficient because we can see only 2 possible topologies based on the 2 distribution layer switches. There is no point to maintain 20 spanning tree topologies. Many of them are identical. So the solution to reduce the number of spanning tree topologies on Per Vlan spanning tree is the multiple spanning tree that I will demonstrate in next video. Thanks for watching.